All right, all right. Good morning, guys. How are you? Can you see my screen so far?
Yes, sir.
All right. So, let's check. So, yesterday we ended up we were talking about electromagnets and stuff. So now, just to continue on that note, how are electromagnets different from magnets? We're just covering a tutorial similar to that lecture that we did. So, what did we say yesterday about? Ones I can undertake, yeah, so that we can differentiate between magnets and electromagnets. So which one of the four is most true? Magnets can be turned on or off. You can turn an electromagnet on or off. Magnets are more powerful. Magnets have a north and south pole. Which one is true about the difference between electromagnets? Comrades, it's time for you to answer now. So is anyone gonna answer? Vanele, you're quiet.
It's B.
What does B say? You can turn electromagnets off. Yeah, that one is fine. That's what we said yesterday. So now here is another one. What is most likely to happen when the switch is closed? A, magnetic field should be produced. B, the nail will rust. C, the battery will explode. D, the wire will catch on fire. What's gonna happen on this one? Jama, you can enlighten us.
I think it's A, sir.
The magnetic field will be produced. That one. D. Now, here is another one. What two forces are required for generators and motors to work? If you can explicitly try, what two forces are required? Electricity and thermal, electricity and magnetism and radiant, magnetism and thermal. Which of the four do you think is needed? Comrades, my time of speaking is over. Do I have to pick all the time? Dutus.
I think it's B, sir.
Electricity and magnetism.
Yes,
What
electricity.
Okay, electricity and magnetism. All right, let's move on to the other one. A motor or generator works on the principle of what? We touched on it for quite some time. There's electromagnetic induction. When a rectangular coil is placed in a magnetic field and the current is passed through it, a force acts on the coil causing it to rotate. Both A and B, none of the above. Which one do you think? Do I have to pick again, gents? We can quickly cover this. Somebody, faster.
A, sir.
What about B? It's not a principle, right? So you are right. It's the principle of electromagnetic induction that we talked about. And then now we touched on electromagnetic induction, the one that we've been talking about. We said the modern day generators, this part which I was talking about for XCOM, right? We say the modern day generators work on the principle of electromagnetic induction. We said this was done by this guy called Faraday, right? But you know, he took that from a guy called Joseph Henry. So they realized that a changing magnetic field produces an electric field. Hence, yesterday we said when you have a magnetic core like that, and then on that magnetic core, you have a coil around it, right? And then if this coil is carrying a current, right? And then if not even a current, we just make a coil like that. This is the magnetic field. If you hold the core, move it to and fro, right? To and fro in that core, you say it induces an electrical current in the wire. And then the opposite is true. If you have a nail and then you put your battery, it goes through the coil. The electrical current flowing through the coil will induce a magnetic field on the nail or iron wire that will be inside the core. So it's vice versa on that one. I'm seeing a hand. I wonder who it is. Let's see. Oh, someone had said B then. So tutorial questions. It's something like this. Can you create a current through a wire without connecting the wire directly to a voltage source like a battery? How so? Anybody who can answer this? We just talked about it now. These are some of the questions that you will get on your exam or test or whatsoever. So can you create a current through a wire without connecting the wire directly to a voltage source like a battery? And how so? Do I have to pick, comrades? We just talked about that now. Okay, let's see. Pila Matlasela, can you help us on this one? The comrade is afraid to talk. Sarah, are you around? Can you help us on this one? If you are there. Sarah Bacchus is quiet also. The comrades. Hannah, are you around? All right. The comrades are afraid of this question. Somebody send a message on the chat said coil a wire around a nail. Yeah, that one works. That's what we've been talking about. We said all you need to do is just have what? An iron nail or whatever ferrous metal, coil that thing around there, right? And then connect the wire like that, right? And then take this magnetic core or whatsoever, move it up and down in the core. So a changing magnetic field will induce a current in an electrical wire. So can you create a current through a wire without connecting the wire directly to a voltage source? True. And that is the way that we were talking about. That was called Faraday's law, electromagnetic induction. So now the answer is yes, the current flows because something is producing an electric field that forces the charges around the wire. It cannot be the magnetic force since the changes are not initially moving. There's something called an electromotive force or EMF. We once talked about the electromotive force in the past couple of days, right? So, but the main thing that I wanted you to understand is written in green. A changing magnetic field through a coil of wire, therefore must induce an EMF in the coil, which in turn causes current to flow. So this is the proper definition, this one written in gray. A changing magnetic field through a coil of wire, therefore must induce an EMF in the coil. That EMF is the one which in turn causes an electric current to flow. So you must get it right. When you just say a changing magnetic field through a coil of wire induces current to flow, I won't give you the mark because you left something very important there on the statement. The field produces an EMF. The EMF in turn causes current to flow. Now, that's how it's supposed to happen. So this is supplementary information. Someone was always asking, Minera, can you give us some stuff? But that's your job, to learn how to find, to research on yourself, to find webs, other sources online. You see, I was doing it initially in the beginning of the semester because I was making you arrive. But now you're becoming facilitators yourself. You can't depend on me. It's the other way around. It's a family, as I told you, everyone is chose to do. You have to look and source out for information. We're teaching you to be transformative, not to be dependent. So, but here are some of the sources that you can watch on YouTube, see what goes on how a generator works, understand how the ESCOM things work and how they fail, etc. So how electric motors work. You've ever wondered what makes that CD or DVD turn in that car radio of yours or DVD that you play at home? What makes it rotate like that? So that's one of Faraday's law, the induced magnetic field. As you can see on the picture there, what do you see? You see a coil of wires, right? And then the silver thing there is encasing, let me annotate so that some of you can see. The wires here, these are the coils. Someone yesterday asked the wires would be insulated, how do the current or whatsoever happen? And I told you that the kind of insulation that we're talking about is small pane. As you can see, there, I don't know what color is this, it's copper, it's whatsoever color, I don't know. But that's a little paint on the wires there. All right, so that's the coil there. And then the silver encasing there, it encases magnets inside there. So now you have a current carrying wire, you have a magnetic field, and then you're gonna get a force. So there's something called, I don't know whether you heard about it in primary or in high school. There are two laws. The other one is called Ian Fleming's left-hand rule, and the other one is the right-hand rule. Right. So what happens here, you have your fingers. One points in the direction of the current, one points in the direction of the magnetic field. Right. Then the thumb will point in the direction of the force. So whenever there's a magnetic field like this, you will curl your fingers. When I'm saying curl, I mean your fingers should curve. Your fingers should curve in the direction of the magnetic field. When your fingers are curving in the direction of the magnetic field, your thumb will give you the what? The direction of the force of propelling that thing. So whenever there is a current, there's a magnetic field, there is an output force. So here, as you can see, they combine the magnet, current carrying wire, then the force is induced on the core, which is inside, it starts to rotate. That's how your DVD spins around. That's how anything with a motor, your blower, which blows air, it's going something like that. This is Faraday's law, the electromagnetic induction. They'll be using a motor. So these are simple electric motors. I'm sure most of you haven't seen motors or you haven't played around with motors. But for some who have seen them or you have touched them, this is what it looks like. You remember what I was talking about. On a DVD, they cover it up with nice plastics here for acoustics so that the disc can sit here. Let me annotate so that the disc can sit here. So that now when it rotates, it just rotates sitting on top of a plastic there. So this is your motor. Inside is encasing magnets, which are entailed with bragger, with coils and brushes in there. And then when you turn on the electricity, it's like what I told you, current, magnetic field, force, which is the output, which tends to spin the thing. So when you look at it, this is the picture of the inside of this thing. There is the silver casings here, different. The coils here, you can see they are painted with sort of blue color, something like that. And then the other armature coil terminals are inside here. Coil terminals is the ends where which you connect, right? Now, here is an electromagnet. This one we talked about. You remember yesterday when we were saying if you want to test whether something is a magnet, you can't just use a metal or a coin and say, is this attracted to another magnet? And then you say this is a magnet. No, you say you find another permanent magnet. You say you find there. You say you must find a permanent magnet. Right. Said you must find a permanent magnet. Permanent magnet. And then test your magnet that you've created against the magnet. So check all the poles of your new magnet against the poles of the permanent magnet. So the north pole of your new magnet must repel the north pole of the permanent magnet, vice versa of the south pole. If your magnet is attracted on all ends to the north pole, then you know, rubbish. That's not a magnet. It's an induced wire or iron nail, which is not a magnet. This is an example of the experiment we're talking about, creating or inducing an electromagnet using an iron nail and a battery, right? So if you bring it inside now, another magnet shoe, you can find out which one is the south, which one is the north on your coil. But however, now, can you see something else? Now, you have a current carrying conductor, you have a magnet here, you have another wire there. So if the north pole and the south pole of these two things, south and north will attract, right? South and north here, they will attract. But however, now, if you change the polarity, as we say, vice versa the battery here, let the positive be negative and let the negative be positive, what will happen? That means now north will be against north, and then south will be against south, if you vice versa the polarity. So what happens? This one will repel and this one will repel. Then the iron nail will turn, right? That's another way of creating a spinning disc or a spinning electromagnet. So what they do, they put brushes like this, curved brushes like this, right? When they put curved brushes like this, these are magnets, right? And then here they put a coil, electric coil, a coil of wire, and then there will be a metal in the center here. But now you know that we have AC, alternating current. Alternating current, it's positive going to the front, negative going backwards. It's in all directions, right? It keeps changing. So now imagine when you have current, which is here, we have a north pole here, we have a south pole. In the first round, what's going to happen? The current is going to come going in a certain direction, and then north pole and south pole will repel each other. Motion will be induced. When AC changes again, now that nail would have turned in such a way that the north pole is on the south and the south is on the north. But if the current AC is changing, that means still it will be north-north, south-south, repelling again. It continues the motion, going. So that principle is adapted here. It's adopted from this thing. When you have your own magnet, you have your south and north, they attract, but you change the polarity here, that becomes north, south. But if you continue changing the polarity of the part, which means these will always meet when they are the same, and which means they are always going to repel. They keep on rotating. All right. I hope that was a bit clear. So how a motor works, the principle, the operating principle of a DC motor is based on the interaction between the magnetic field of a rotating armature and the magnetic field of a fixed stator. So you see what they did. These are the stator magnets, right? The magnets are fixed. The gray ones here. These are the stator magnets. They are fixed. But now inside the current carrying coil, these are the coils, as you can see them. They are called rotor coils there, right? And then there's a commutator. That's a copper ring holding, it's just connected to the rotor coils. And then you have the brushes, which are connecting to AC current, right? So now, is the AC changes there, or even if you use DC, if you use the DC, still the same. If let's start with the DC, direct current. If you induce it here, these will be moved to a certain direction, right? And then on the gap, there will be no motion, right? So once it spins, it will keep quiet. Or on the part where there is a gap, there will be no force pushing it. But when it overlaps on the other side, it will be pushed again. Once it overlaps, pushed again. That's how on DC motors it works. But on AC motors, there's no gap here, right? There's no gap there. This only changes because of the alternating current that keeps changing. When alternating current keeps changing, which means on all opposite ends, it's always repelling, thereby producing motion. Now, they're going to ask you what is an armature. All right, an armature is a revolving structure in an electric motor or generator wound with the coils that carry the current. I showed you these coilings here, which are shown in silver. The other ones are shown in copper, the coiled one. That's an armature. All right, so if the north pole of the armature is attracted to the south pole of the stator and vice versa, a force is produced on the armature, causing it to turn. Right. Commutation is the process of switching the field in the armature windings, right? That's alternating current or changing the polarity to produce constant torque in one direction. So the commutator is a device connected to the armature, as we saw previously. The commutator, as you can see here, is connected to the armature, the rotor coils. So in case of an alternating AC generator, the coil is through which the current flows, the coil through which the current flows is stationary and magnetic field is rotating. So you see the difference. The one that we've been looking at, it was the coil inside that is rotating. The magnetic field was fixed, right? But now in the case of an alternating generator is the opposite. The magnetic field is the one which is changing, which is rotating, but the wires are the same. So you see what this one is. This one is the example of what ESCOM does. This is ESCOM generators that they talk about. So what happens is on ESCOM, you have a magnetic core or magnetic bar like that, and then it's in the middle of a wire, right? Coils of wire. So what happens is this magnetic field is attached to rotor plates, usually rotor plates. That when water comes, it pushes this rotor plate. When it pushes that rotor plate, imagine that rotor plate is a magnet. It has a north pole and a south pole. When water turns that turbine around, which means the magnetic field is changing, right? As we said, once the magnetic field changes around the wire, you generate an EMF force. That EMF force then induces current, right? So that's how electricity reaches your houses. You have a river or waterfall coming down, and then you have turbines which are magnetic. That's a turbine. There's a north pole and the south pole, and then it's around the current, a coil of wire. When this magnetic field changes, because the water is pushing the plates, when water falls on the plates, they rotate. So when the magnetic field is changing, it induces an EMF force on the wire and thereby producing an electric current, which thereby comes to our houses that use. So now you know how ESCOM generates electricity. When they say the power station is broken down, it's either these turbines are broken or the wires have been bent or the commutators, the brushes, etc. have broken down, there's a fault. So these are the power stations. This one is from a hydro electric power station. This is an AC, alternating generator, alternating current generator, which is a hydro power station. Even a coal powered station works the same, but instead of water pushing the turbines, in the coal power station is steam. They heat up water, which is on a container, and then that steam is, when we did matter or particles, when gaseous matter gains more energy, what does it do? It gains more kinetic energy. Once it gains more kinetic energy, which means it's under pressure in that container, thereby it pushes the turbines. When it pushes the turbines, that's a changing magnetic field, which induces an EMF force on the wire, thereby inducing an electric current. Then you have, either way, you explain how a hydro power station works and how the coal power station works. Right. Now They're talking about the armature of a DC generator. That one was an alternating current generator, and what using the ESCOM things, which give us the alternating current. But how do you generate direct current? Right. So the armature of a DC generator rotates while it is fixed electromagnet. So you see the difference here. If you want to produce alternating current, you constantly push or move the magnet so that it induces a change in magnetic field. But now when you want the reverse, you want direct current, what you're gonna have to do is to rotate the wire but keep the magnet constant. All right, this is what happened. It's the reverse of what we're talking about the last week. Yeah. So the main construction difference between two machines is in their output connections. DC generator, AC generator. All right. Here, magnets are rotating. On the DC, the coil inside is the one which is rotating. Don't worry about this. This is about a practice for doing a prac or what's etc about it. So now, guys, I'm done with this topic. All right, sorry about that, guys. Now I was saying I'm done with that part of magnetism, electricity and magnetism. I've shown you how those things works. Now, yesterday after my meeting, I talked with Moodle. So what's gonna happen is this. I talked with Moodle. What's gonna happen is this. I want to write it down. Uh, I sent an email last night. So the lectures will continue online, right? But now the pracs are on campus. And one thing that I wanted to come clear about, guys, after my meeting, I learned the truth about how this is supposed to happen. Whether you have transport or you don't have transport, that's not my business. So actually, I've been listening and trying to be humane about it, that some people are crying about transport or what or etc. Some people were telling me that the EPE 131 is going to be the only module that is making us come to campus. By university policy, after my meeting that I had yesterday, I learned that that is none of my business. That's your own problem to sort out. I spoke to Mugli, I spoke to the other big bosses. They told me that's none of my problem, it's your problem. When you registered in university, you knew that at a certain point, COVID is going to end. So whether it's my module alone or whatever module which brings you to campus, you were supposed to come by law, which says 50%, 50%. So, but in order to be humane, I decided that no, I'll keep the lectures online so that people don't come every day to campus, to campus. How you're gonna reach campus, what I don't know, but that's gonna happen whether you like it or you don't. So the lectures are gonna continue online, but pracs every Wednesday. The group that's coming on a Wednesday will have to be on campus. On the day of the test, then everyone is gonna be on campus to write on campus. The venues I'm gonna announce as soon as they give me the venues for the tests. And then the venues for the pracs, I'll post them on Monday. Mr. Ndaonde is finishing up. He has ordered the batteries for our pracs, so they are arriving on Friday. And then next week, as you saw on LAN, I shifted the pracs by 1 week. So when the batteries arrive next week, Wednesday, the first group starts. So that story of emailing me, telling me about your transport or how you are, what, please don't bother. Sort it out yourself, how you're gonna get there, and make sure you get there. If you don't, it's fine. We'll see you on the catch up. If on the catch up also you can't, we'll see you later. Aisha, yes, you can speak.
Hi, sir.
Yeah, how are you?
I'm good, and you?
Yeah,
So the issue is not about transport. It's about the lecturers telling us on time, like a day or two before we need to be on campus. This is the venues and all. So we know we can organize that transport to get there. Because organizing transport on such short notice is very stressful for us. So telling us on time what's happening, you see, it's more of less of stress on us. Do you understand what
I
I'm
went.
trying to?
Well, yeah, I understand very well. Well, with our module 131, everything was laid out the very first day we started on campus, that what is going to happen on when. The only change that came was when people didn't understand that it is by force from the university policy that people should come on campus. So in the very beginning, yesterday, we were kind of confused whether should people come about that. This is not the only class which is having problems. So it was kind of a meeting
Yes.
to fix everything. But otherwise, for our module 131, everything is there on the course outline. The dates were set a long time ago. What's missing is a venue. So now
Yes.
you know, pracs our campus. There is 1 week preparation for you to arrange your transport. Pracs are gonna start next week on Wednesday. That's when the first group is gonna come. That first group, I told it way before sim break that it's supposed to come to campus and do a prac on this Wednesday. But unfortunately, the components were not there. So in terms of arrangement of time, there's an extra week to arrange transport, which is for a prac, which starts next week for the first group of the prac. Then the next group has 2 weeks to prepare for its transport. The third group has 3 weeks, and so on until we are done with the pracs. And then for the tests, I talked about the tests before we could even study or anything. And I kept on reminding people even about test 1. So the same thing is going to happen about test 2. It's there on the course outline. I discussed it. That is going to be written online. I discussed the course line more than 2 times. So thank you, Aisha, again for reminding me to make another reminder again right now about that. There is a test which is going to be on campus. So
Yes.
you've done a
Thank you,
great
sir.
thing by asking that to me. So I hope that clarifies everything about what people were uh, most concerned about.
It does. Thank you.
Any other questions? I think from now onwards, everything is sorted. What's left is the venues that are going to be posted. That test is going to be on what venue. The pracs in your department, Mr. Ndaonde's labs. You all know them, Mr. Ndaonde's labs. He and I will be there outside. We will fit you into the labs, distribute you into the labs which are there, and then the prac starts. So otherwise, I think everything is settled now. Everything is going like a well-oiled machine now. No stories, no excuses. And I hope it helps those who are crying about transport that we're not going to come to campus every day. Any other questions before I go? Comrades, anyone who has a question now, so that I can clarify it, so that later I don't get emails or texts on my phone, which I don't want on my phone. Everything is now clear, right? So if everything
Sir,
is clear, then I guess here is Paruk. Paruk, what's up?
Good
Yeah,
day,
I'm
sir.
listening.
I would just like to know if you can
Yeah.
clarify for us in any way how can we prepare for the practical? beforehand?
Tomorrow is Wednesday. I'll come and show you how the practice is gonna be done.
Okay. And with regard to the booking of the practicals, we can choose any of the weeks, or how do we go about just booking the practical?
We explained that a long time ago. The choices of booking, as I know, every day is booked. So I'm surprised why you haven't booked yet. How come you haven't booked and you don't know about that? Let's start from there. You answer that, then I can help you forward.
I don't know. I've been looking on my Learn 2022 and it only popped. I only saw the booking setup thing on Learn somehow. I only saw it the other day, so I wasn't sure about it until now.
This answers one question for me. Or let me ask one question. Did you bunk one of my lectures before? Because I came to class, I explained to people how they should book. And then afterwards, I wrote an email and a message on WhatsApp that people should book. I've opened the slots, and then you book according to the date which you think you are comfortable with. And then people went online. I can see
Yes,
online
yes.
here, they already, yeah. So now when you're asking that question, I'm surprised. Do you understand what I mean?
Yeah, no, I understand.
All right. So what you can do, go straight there right after the lecture now and try to book a slot. If there is no slot for you, you tell me.
Okay, I'll go and
I'll
check.
check and see where I can insert you on those dates.
Okay.
All right. Laka stuff. Next
Okay,
question.
thank you.
Who's next, guys? What she's actually saying is true, because almost 300 students, there's only 121 people who have responded, 78 people who have not answered. So that's quite interesting, because you're gonna fail. Actually, I don't want to lie to you. You're gonna fail if you don't do the track. It's one of the GP requirements. So if you don't do this practice, you're gonna fail. Trust me. I'll send another email to tell you. You don't do the practice, you won't even write the exam. You'll fail. And the way it works from my meeting that I had yesterday, the announcements are there as evidence on land, and everything has been the lectures, the register for me. She actually sent me the registers during the sim break. So I'm actually, for me, I'm actually safe as your lecture. I wonder what about you, because the secretary marks the register for me. I'm using this, so which means it's easier for them to automatically check the class list. So you don't do the prac, I'll just send you to the, trust me, you don't do the prac, you fail. You won't write the exam. Any other question? Yeah, Sarah.
Hi, sir.
Speak, Sarah. Yeah, how are you?
Good at you. I just wanted to clarify something because I don't want like any confusions or anything. So the issue that I had was not that I didn't have transport or not that I wasn't having any other lessons on campus, because if you required us to be on campus, I was going to be there regardless. But I understand the issue that you didn't have a venue. So the problem yesterday was that because I didn't get any response about whether we were starting lessons on campus yesterday, because when I had emailed you and messaged you, I didn't get a response, and then it was already 9 o'clock. and it takes me about 45 minutes to get to campus. So I would have to leave my house to be on campus on time for the lesson yesterday. So if we weren't informed about the venues, like you told us you was going to confirm the venues with us. So I was left wondering, were we going to have the lesson or not? Because if we didn't have a venue, how were we going to have the lesson? And I didn't want to go all the way to campus for nothing, because like I said, I don't have any other lesson on campus other than for this module. So if I went there, then suddenly you had said, oh, but we didn't have a venue organized, then you see, so then that's why I needed a response, but I wasn't getting a response. So then that was just stressing me out because we weren't being communicated with. But I do understand that you're normally very well organized, and I have read the course outline and stuff, and I saw that there was nothing about venues. So when we didn't get a confirmation about the venue, that's where the stress came in. And like I said, I didn't know if I had to go to campus or not.
Sarah, don't worry, we're all good. as long as we have sorted out our problems, everything is fine. Don't worry, guys. Why are you scared? Don't be scared. Yeah, I told you we'll be fine. As long as the family, you know what your family does. I told you, everyone is a chore in the family. As long as I cook, someone washes the dishes, I clean, somebody sweeps the yard. We are fine, guys. Don't worry. So we have solved that one. So don't worry. Just enjoy the lecture as usual, as we always enjoy. So don't stress about it.
Okay.
But important things that you should know. Don't miss any of these what is it called? Assessments and assignments. Unless if you're critically ill, sick, or there is a death in the family, things like that, then that's understandable. But don't put yourself in unnecessary trouble. Because to be honest, I was relieved after yesterday's meeting when even the past week when the secretary I emailed her to ask how do I follow up with it. She was like, don't worry, I checked the registers for you and stuff. I was quite relieved that at least the technology is now helping us nowadays. So don't put yourself in unnecessary problems like some other students. You know, there are some other people who have never attempted a thing. They are going to come now when they hear that they are going to fail. That's when they are going to surface. But then how do you explain your story now? Because they are going to pull up the registers, and then they are going to pull up even the land registers and see how many times you ever went online, how many times you ever came on Zoom. So your story won't even help you unless now you have a very long sick note from a doctor who says you were sick the entire 3 months or so. So don't put yourself in unnecessary strains. But otherwise, I will see you face to face on pracs and on tests. The lectures will continue online, and then I'll continue posting some of the videos of the lectures which are critical online, and then etc. But the notes will always be there. But the lectures, I'll post those which are critical, which I feel like this one is critical. People will not be able to catch up. And then from there, everything will be fine. Any other questions? I have another lecture now. I have a class with some students.
So quickly about a class rep for this module,
You
is
found
someone
one?
a class rep?
Yeah, have you found one?
I don't mind being class rep, so
If you don't mind, just email me about it, and then I'll make it show. I'll make it. I'll post it on our lane that you are the class
okay.
rep.
So,
It's
all
easier.
right,
If you guys have problems, you will tell me what problems you're having.
I will email you, sir.
All right, please. All right, I'm going, guys. I have another class now in half past.